Hello, welcome back again to Unit 2 of our Module 1. Our today's topic is Vector and Scalar 1. In our last video, we discussed about unit, dimension, and we talked about the importance of units in scientific measurements, and we also learned how we can convert unit from one form to another using chain method. We as well learn about prefixes, which are scientific notation that we use to represent our numbers. For example, when you use kilo, nano, micro, and so on to represent larger numbers. In our last video also, we also talked about using dimension analysis to probe the relationship between physical quantities. So with this now, we can go in more deeper today and learn about how we can classify these physical quantities into vectors and scalar quantities. So let's start. So we understand that there exist many physical quantities in the natural world that we use on a daily basis. For instance, we are familiar with the physical quantities like length, mass, time, temperature, and velocity. The number of physical quantities in nature are numerous, and we can divide these quantities into vector and scalars. In this unit, you will learn how to add, subtract vector using different methods such as graphical method, head-to-tail method, and parallelogram method. At the end of today's video, you should be able to explain the difference between scalar and vector quantities, adding vector using head-to-toe graphical method, adding vector by drawing them in parallelogram arrangements, subtracting vectors using head-to-tail method, calculate the component of vector on a given coordinate system, showing them in a drawing. So what is a vector? A vector is a physical quantity that has a magnitude as well as direction. And a vector follows certain rules of combination which we examine in this chapter. A vector quantity is a quantity that has both a magnitude and a direction, and thus can be represented with a vector. Some physical quantities that are vector are displacement, acceleration, velocity, and so on. So what do we mean by scalar? Scalar is those physical quantities which possesses only magnitude and no direction in space, such as temperature, time, volume, and speed. So one way to look at it is that when we say speed, we mean speed to depict the distance over time without requisite knowledge about its direction. But the moment we talk about velocity, we are also talking about displacement or distance with respect to time like speed, but in this case, we also require the knowledge of direction. So a velocity is a vector quantity, while speed is a scalar quantity. For complete description of scalar quantity, we need a unit and a numeric value, here magnitude. In this unit, our vector notation will be written in a form of an arrow pointing to the right above it over an italic symbol. For example, you can look at our force here. It's an example of a vector quantity, and the arrow on top is pointing towards right. At times in some textbook, you may find a vector quantity written in bold. Our weight, which depicts the effect of gravity on a mass, is also an example of a vector quantity. Velocity is also another type of vector quantity. All of these vector quantities have both magnitude and direction. Addition of vectors using graphical method. Vectors are added in a special way because they have magnitude as well as direction. By implication, simple arithmetic cannot be used for adding vectors if they are not in the same direction. But we can use simple arithmetic for vectors if they are in the same direction. An example is a one-dimension vector. Let's consider an example of a one-dimension vector system in which, for instance, someone jogged for 8 kilometers towards the east, and in another instance, the person jogged 6 kilometers towards the east. So we can add these two vectors containing the magnitude, which is the numeric number, and the direction being east as the vector. So therefore, the addition of these two vectors, 8 kilometers and 6 kilometers, becomes 14 kilometers, which is just 6 plus 8 kilometers. While on the other hand, for instance, if at a certain time the person jogged 8 kilometers towards the east, 8 here means the magnitude of the vector, while the east direction signifies the direction. But in another instance, it jogs 6 kilometers towards the west. So the resultant vector becomes the difference between these two vectors, and that gives us 2 kilometers, which we have just done 8 minus 6. Let's consider another example. Suppose we have a particle which moves from 0 to 10 kilometers as depicted on the screen, and in another instance we have this same vector which moves around 4 kilometers, and in another instance we have another vector which moves 5 kilometers up north. So these are vectors that are perpendicular to one another. So how do we determine the resultant of the vector? So we draw the resultant vector as the line joining these two vectors, and this gives us our dr, which is the sum of the vector 1 and the vector 2. But this sum here has to do with parallelogram. So to find our resultant vector for this combined vector system, we have to use parallelogram theorem, which is given as d squared, which dr squared is equals to the sum of our two vector components, which is our d1 squared plus d2 squared. And if we are looking for dr, we square both sides, so we have this. Alright, and we have defined our d1 to be 10 and our d2 to be 5. This simple arithmetic will give us 11.2 kilometers.